Welcome. In this video, I'm going to show you how to find the second derivative of this equation here using implicit differentiation. So let's begin. We need to find the derivative with respect to x of both sides. So on the left-hand side, we have the derivative with respect to x to the fifth plus the derivative with respect to x of y to the fifth equals 0. Since, again, the derivative of a constant is just 0. Now, this is fairly straightforward. This is just 5x to the fourth. That is a straightforward application of the power rule. Now, to find this derivative, recall, implicit differentiation is just applying the chain rule. What I'm saying here is that we're saying y is some function of x, and we don't know what this function of x is. So y to the fifth is equal to g of x to the fifth power. So if you're applying the chain rule here, that is, you're finding the derivative with respect to x of this function g of x to the fifth power, you first start by finding the derivative of the outer function. So that's 5 times the inner function to the fourth power, and the inner function is g of x. And then we multiply by the derivative of the inner function, which is just g prime. So since y equals g of x, y prime is g prime of x, or we can just write dy over dx equals y prime. So this derivative here is 5y to the fourth times dy over dx. And again, that equals 0. So now let's go ahead and subtract 5x to the fourth from both sides. And then divide both sides by 5y to the fourth. So the first derivative here is negative x to the fourth divided by y to the fourth. Okay, so now let's use this to find the second derivative. Alright, so here is our first derivative. Now I still want to take the derivative of both sides with respect to x. So on the left, we have d squared y over dx squared is equal to, and on the right, we need to apply the quotient rule. So that is, I need the derivative of the numerator with respect to x times the denominator minus the numerator of negative x to the fourth times the derivative with respect to x of y to the fourth of our denominator, and this whole quantity divided by y to the fourth squared. So this is negative 4x cubed times y to the fourth plus x to the fourth times 4y cubed dy over dx and divided by y to the eighth. So seeing as I have x cubed and y cubed in common, I'm going to factor those out to the front. And that leaves me with this expression here. Well, we have a little more information. That is, dy over dx is this expression, or this value here, negative x to the fourth over y to the fourth. So up here, I'm going to continue my work. That is up here. And I'm going to replace this dy over dx with negative x to the fourth, y to the fourth. So this is x cubed, y cubed times negative 4y plus 4x times negative x to the fourth over y to the fourth power. And this is divided by y to the eighth. So it's time for a little ninja algebra here. And what I mean is, let's multiply the numerator and the denominator by y to the fourth over y to the fourth so we can get rid of this denominator here. And that leaves us with negative 4 times y to the fifth minus 4 times x to the fifth. And this is divided by y to the 12th power. Okay, so remember our original equation was x to the fifth plus y to the fifth equals 25. And I have a y to the fifth, and I have an x to the fifth. So in this next step, I'm going to factor out this negative 4 to the front, while also cleaning up the y's in the numerator and the denominator. So now that I've cleaned this up, clearly I can replace x to the fifth, y to the fifth with just 25. So this second derivative is just equal to negative 100x cubed over y to the ninth. So again, what we just found was the second derivative, that's d squared y over dx squared of this original curve. We found that to be negative 100x cubed over y to the ninth power. And we also found its first derivative here. I hope this video has been helpful.